All right, we're finally getting to the end of this exercise. We're going to do examples 15 to 17 in one go here. Right, so we're just going to use those rules we've learnt regarding cos and the magnitude of, well, in relation to unit vectors or the axis. So the first one here we've got is a 2i minus j. What is its magnitude and what angles do they make with the x-axis? All right, so let's have a look at part A. This is true for both of them. So the magnitude of A is equal to the square root of 2 squared plus minus 1 squared. Okay, don't forget. Yeah, don't get tricked out by that. So that equals 4 plus 1 is the square root of 5. And the magnitude of B is equal to the square root of, we've got 1 squared plus 4 squared plus minus 3 squared. Now I can draw my line. 9 plus 16, 25 equals square root of 26. So what angles do they make with the y-axis? So just using that rule, let me just add a little bit more room here. Part B says, so I know that, well, we're looking with regards to the y-axis, right? So A2, that's right. So cos of, using the thing from the thing, equals A2 on the magnitude of A, so to speak. Okay, so that means that cos beta is going to equal A2 in, for A is minus 1 on the square root of 5. So beta equals cos to the minus 1 of minus 1 on root 5. I'll do that in a second on the calculator because I don't know about you, but I don't know that in the top of my head. And the other one is also, let's just use this so we know we're talking about different things. I'm just using the beta and A2 because that was just what we learnt so far in the exercise already. So cos beta for this one, it's playing up again. Okay, is equal to A2 divided, well, in this case we're looking at B as our vector, by the way. So B2 divided by the magnitude of B equals, so B2 in this case is 4 and the magnitude was square root of 26. So that means that, I should put a little arrow there. I'm just using this because I'm running out of space, which is a stupid thing to say on a OneNote, but anyhow, so that means that beta has to equal inverse cos of 4 on 20, well, root 26. Let me pause this video and get that done on the CAS. All right, so the first one is, am I recording? Sorry, probably am. Yes, of course I am. The first one is 116 degrees. And the second one was 38. So 116.5 and 38.3. So equals 116 point, oh God, I think it was 8. Let's put this to make sure we cover bases, approximately 116 degrees. And where's the 116.5, 116.6, 138.3. Sorry, 30, it was 38, wasn't it? 38.3. 38.3 degrees. All right. Now this question looks like a lot more fun. We get to draw some pictures. Isn't that does sound great, doesn't it? All right. So we've now got this, got our X and Y. And let me redraw that. Okay, that's a bit better. X, Y. So we've got some line that's going to be 5 long, okay? Our vector, sorry. And I can see it's 150 degrees. So whatever, let's pretend that's 5, okay? It is going to be 150 degrees, which is something like that from the x-axis, and which means that it will be 150 minus 90, okay, because from the y-axis equals 60 degrees. So we've got this 60, we're going to have this, if it works, something to do with 60 here, okay, and I might change the color, so that's about right there. And let's pretend that's 5 long, okay? So let's call this vector A. And I know that the magnitude of A is equal to 5. Now, I won't need to use I know I won't need to use a calculator for this one, because if that's 60, then that means we've got this little 30 degrees in here, right? So if I go back to, if you remember cutting the equilateral triangle in half, I've got a 30, 60, and a 90, and whatever this is, this will be, this side here is half of it, and this side here is root 3 on 2 times it, okay? And the reason why I say it is because when we use the unit circle, we always said that was 1, didn't we? So in this case, I know it's 5. So this here will be, what color? Let's use a pink. So I know that this here will be 5. What's wrong with this pen? 5 times root 3 on 2, and let's use a yellow. That is not to scale at all. 5 on 2. Okay, so and so this is my I, but of course don't forget that I is in that direction. Okay, so this here is, so that would be, well, in the length of 1, whatever that is, I is that way. Okay, and J is up. That's why I use the red and green, same as in the GeoGebra, by the way. And J is up, right? So it's negative I direction and positive J direction. So that means that this vector here, this two-dimensional vector, which I've called A, will be equal to 5 times root 3 on 2 times I, sorry, minus 5, okay, because we're in the minus direction, plus 5 on 2 in the J direction. Okay, and that's what this point is here. That's what this vector is here, A. I might put a little arrow there to make sure it's clear that it's a vector. All right, and yes, this is the last one. So we're going to let I be a unit vector in the east direction, and J be a unit vector in the north direction. So it's just like our vectors. Show that unit vector northwest 60 degrees. So let's draw that. So north and then west 60 degrees is something like this. So there's 60 there. So in all up, that's 90. But oh, we've just got we don't need to do anything here. Okay, so the unit vector is whatever vector we've got is going to be going in this way. Okay, and if we made this 1, then that'll be a half, and just like we did before, okay, root 3 on 2, okay, and but in the negative direction. Okay, so that will do for this. The other thing, I mean, if we were to, if we were to use this in using our cos and sine, then once again you could look at it that yeah, so it has to be in the you can just write it in degrees too, right? So so from here to here that'd be 150 degrees, which is minus cos of 30 degrees, okay? Because we're moving in this direction. So our unit vector a hat will equal minus because I was going to say, so it's actually equal to cos of 30. Well, sorry, cos 150, which is the same as cos minus cos of 30 degrees. Pen, don't make me scream. Minus cos of 30 degrees times I. Okay, so in the I direction, plus cos of 60 degrees. Okay, which is, once again, if I flip this triangle around, or it's equal to sine of 90 degrees, hopefully you know that by now, in the J direction. Okay, and the reason we've done that is so it's like what we've done for the unit circle, and that's one way to think about unit vectors, is they're obviously all related to the unit circle. Okay, so if the car starts 3 kilometers in the north, so it's 3 kilometers in this direction, find the position of the car with respect to the starting point. So it is just going to be 3 times a hat. I should have actually, let me write those numbers in from part A. Equals minus root 3 on 2 I plus 1/2 of J. And so for part B, we're in green now, are we? Car drives 3 kilometers in that direction. So then A, 3 times A hat equals minus 3 on 2 root 3 I plus, excuse me, pause this. All right, that's looks like it's fixed now. I plus 3 times half is 3 on 2 J. And now the next question is, the car drives 6.5 kilometers due north. Find the position of the car. That's easy. The pen's not being easy. All right, so so the position vector of that is I'm going to call this car 1 because I don't know how many more we're going to do. So that's equal to, I'm just going to call it C for car, start with. So due north is just 6.5 times J. The distance of the car from the starting point, that's just 6.5, isn't it? Whoops, I have made a mistake. It's going to equal, next point is equal to minus 3 root 3 on 2i plus 3 on 2 then we can plus our 6.5j, or another way of saying 6.5 is 13 on 2j. Actually, it probably works out better, because then when we add them together we get none of this changes, plus 16 on 2 is 8j. Alright, now the next question was, what's the distance of the car from the starting point? So it started here and it's gone up. Okay, so so we're at this point here. So what we're going to look at is the magnitude of C. Okay, so that is, C is moving along our 3 kilometers plus another, well, it should be double that, 6.5, and then now what is this vector? That's what we're looking at. All right, so the distance of, so that's C, I should write over there. So that equals the square root of minus 3 root 3 on 2 squared plus 8 squared equals, so we've got 9 on 4, 9 times 3 is 27 on 4 plus 8 eighths is 64. 4 times 6 is 240, 256 equals 256, 276, 283. On 4. I don't know about 2. I'm not gonna, I can put the half out the front, but I don't know much about 283. So that must be its magnitude. And the next question was the bearing of the car from the starting point. So it is bearing, so what is its new angle? So its new angle is, let's just work out the angle from, I think 8, the 8 might be the easiest one to use, so because then we'll get 360, take away that. Okay, cool. So we'll look at, we'll think about that angle here, which would be, if we went up here, this angle here will be beta. So cos of beta is going to equal A2, well in this case we've got C, divided by the magnitude of C, equals, C was 8, C2 was 8, sorry, divided by a half on the square root of 283, or in other words, it's equal to 16 on the square root of 283. Excuse me while I use the calculator. Just pause for a sec. All right, so I end up with this angle here, 17.99, so basically 18 degrees. Which, by the way, if you have a look, I tried it at first and it just gave me this one. The reason why this one gave me an exact answer is because I put a little decimal place there. Just a little hint. All right, so what I worked out there was 18. So that's that means that B. Well, I should write out. It was cos to the minus 1 of 16 on 283, which is what was it, approximately 18 degrees. So if we think about, as I said, we got our angle here is 18. So we're bearing 360 degrees minus 18 degrees approximately equals 340. Well, bearing, yeah, 342 degrees. I think you put a T there to say it's bearing, but that'll do. All right, good luck. We've actually come to the end of this exercise. Can you believe it? See you in class.